Welcome back to the Solutions Manual. In this video, we will solve the problem F7-1 from RC Hibbeler Engineering Statics 14th edition. According to this problem, we have to determine the normal force, shear force, and moment at point C in this beam. So to solve this problem, first of all, we have to draw the free body diagram. So the point A is spin supported. So we have a vertical support reaction and the horizontal support reaction. The point B is roller supported, so we just have a vertical support reaction. Let's label them. So this right here is AX, this is AY, and this is BY. So now we can apply our equations of equilibrium. So my first equation is summation of moments at point A equals to 0. I am considering counterclockwise direction as positive. Since the line of action of AX and AY is passing through the point A, so these two forces do not have any momentum with respect to the point A. So AX and AY will not produce any moment about the point A. This 10 kN force is trying to rotate the beam in clockwise direction about the point A, so the moment produced by this 10 kN force will be taken as negative. And the moment arm is 1.5 meters. This 15 kN force is also trying to rotate the beam in clockwise direction about the point A, so the moment produced by this 15 kN force will be taken as negative. So we have negative 15 and the moment arm is 1.5 plus 1.5 plus 1.5, so 4.5 meters. The support reaction By is trying to rotate the beam in counterclockwise direction about the point A, so the moment produced by this By force will be taken as positive. So we have positive By, and the moment arm is basically the length of this beam, so 6 meters equals to 0. So upon simplification, By comes out to be 13.75 kilonewtons. Similarly, we have to find the other support reactions. So for AX, we can do summation of forces in x direction equals to 0. I am considering right hand side as positive. So we have just a single force AX. So AX is 0. Now for AY, we can do summation of forces in y direction equals to 0. I am considering up direction as positive. So we have AY minus 10 kilonewtons minus 15 kilonewtons plus By equals to 0. So we have AY minus 25 and the By is 13.75 kilonewtons equals to 0. So upon simplification, AY comes out to be 11.25 kilonewtons. So these are our support reactions. Now we have to find the internal forces at the point C. So if I make a section right here, and we can consider either parts across this section. Either you can consider the right hand side of this section or the left hand side of this section. Both will give you the same answers. I am going to pick the right hand side of this section because I would have less forces. So if I draw it separately, then it would look something like this. We have a force of 15 kilonewtons. We have the support reaction By. We have the normal force NC. We have the shear force Vc, and we also have a moment reaction. I am considering it in the clockwise direction. Let's label them. So this is 15 kilonewtons. This is the support reaction By. This is the shear force Vc. This is the internal moment M. And this is the normal force Nc. So now we can apply our equations of equilibrium. So my first equation is for normal force Nc. So we can do summation of forces in x direction equals to 0. I am considering left hand side as positive. So we just have Nc. So Nc is 0. This is our first answer. And now for the shear force Vc, we can do summation of forces in y direction equals to 0. I am considering up direction as positive. So we have Vc minus 15 plus By, and By is 13.75 kilonewtons equals to 0. So upon simplification, Vc comes out to be 1.25 kilonewtons. So this is our second answer. And now for the internal moment M, we can do summation of moments at point C equals to 0. This is the point C. I am considering counterclockwise direction as positive. Since the line of action of Vc and Nc is passing through the point C, so these two forces do not have any momentum with respect to the point C. So Nc and Vc will not produce any moment about the point C. But we have to consider this internal moment, which is clockwise, so we would take it as negative. This 15 kilonewton force is trying to rotate this section of the beam in clockwise direction about the point C. So the moment produced by this 15 kilonewton force will be taken as negative. So we have negative 15, and the moment arm is 1.5 meters. The support reaction By is trying to rotate the beam in counterclockwise direction about the point C. So the moment produced by this By force will be taken as positive. So we have positive By, and By is 13.75 kilonewtons. And the moment arm is 1.5 plus 1.5, 3 meters equals to 0. So upon simplification, M comes out to be 18.75 kilonewtons meter. So this is our third answer. So this is it for this problem. I hope you would find this video helpful. If you do, please make sure to subscribe to this channel and also turn on the bell icon for the daily updates. And if you have any questions or any doubts in the free body diagram or in the equations of equilibrium, then feel free to ask in the comment section, and I will try to answer them as soon as possible. Thank you.